Modern fighter jets and commercial aircraft use gas turbine engines, commonly referred to as jet engines. Today, the most widely used type is the turbofan engine. Commercial airplanes use turbofan engines with a high bypass ratio, while fighter jets use those with a low bypass ratio. We will explain the differences between the two shortly. In general, gas turbine engines or jet engines operate by sucking in air from the outside using a compressor. This compressor compresses and heats the air, increasing its pressure. Then, fuel is mixed with the compressed air and ignited. The combustion reaction produces heat, which causes the air volume to expand many times over. The hot combustion gases shoot out the back of the engine, generating thrust. Before exiting the nozzle, this jet of air passes through turbine blades. The force from the combustion gases causes the turbine to spin. The turbine shaft is connected to the compressor shaft, so when the turbine spins, it also drives the compressor. This cycle repeats continuously. Since the engine draws in outside air, anything in the air, including rain, can be sucked into the engine. So what happens when a jet engine operates in heavy rain? Doesn't rainwater interfere with the combustion process? As we know, water and fire don't get along. How can a jet engine or gas turbine engine withstand operation in the rain? Currently, the most commonly used jet engine type is the turbofan engine. In a turbofan engine, there is a large fan in front of the compressor with a diameter larger than the compressor itself. Not all air goes into the compressor. Some of it bypasses it and flows around it. This airflow is known as our bypass airflow. In commercial aircraft, the fan has a relatively large diameter, allowing more air to pass through the bypass. This is called a high bypass turbofan engine, which provides better fuel efficiency, making it ideal for commercial aviation. Fighter jets, on the other hand, use low bypass engines with smaller fan diameters, resulting in smaller overall engine size. Even so, there is still some bypass airflow in fighter jet engines. When operated in heavy rain, only a small amount of rainwater gets into the compressor, meaning only a small amount ends up in the combustion chamber. Most rain droplets pass through the bypass airflow. This is because the fan rotates at high speed, and water droplets, which are heavier than air, get flung outward due to centrifugal force. As a result, most rainwater follows the bypass flow and doesn't interfere with the combustion process inside the engine. However, a small portion of water may still enter the compressor and eventually reach the combustion chamber. But this is generally not a problem. The small amount of water is quickly vaporized due to the extremely high temperature in the combustion chamber and is expelled along with the exhaust gases. Turbofan engines are designed to withstand rainy conditions, even with a high volume of water. Before being used, jet engines undergo a series of tests, one of which is the water ingestion test. In this test, water is deliberately sprayed into a running jet engine to verify its durability under extreme conditions. Now, what about other types of jet engines, like turbojet engines? Turbojet engines don't have a front fan and therefore have no bypass airflow. As a result, nearly all water droplets that enter the engine pass directly through the combustion chamber. Again, this is not a major issue. As mentioned earlier, the high temperatures cause the water to vaporize and exit along with the exhaust. In fact, in the past, water was intentionally injected into jet engines to increase thrust. One example is the KC-135 aircraft, which used the Pratt & Whitney J57 turbojet engine. During takeoff, water was deliberately injected into the engine to boost thrust. This method is known as water injection. Besides the KC-135, Water injection was also used in other aircraft such as the F-80 Shooting Star and the early versions of the Boeing 707. While in general water doesn't significantly disrupt combustion, an excessive amount of water could potentially extinguish the flame in the combustion chamber. However, there's no need to worry. Jet engines are equipped with igniter plugs, which use electrical sparks to reignite the engine if necessary. Once ignited, combustion continues as long as there is airflow and fuel. If the flame is extinguished for any reason, the igniter plug will automatically fire again to restart combustion. In conclusion, jet engines, whether turbofan or turbojet, can still operate even in heavy rain.